So before our next coffee break, the talk Machine Learning, the Engine Behind Modern E-Commerce Search, will unpack the technologies powering e-commerce search engines. It covers everything from semantic search to personalization, revealing how these systems enhance the online shopping experience. Let's welcome Milutin Studen, a machine learning research engineer at SmartCat. Milutin, please join me. Can I get a mic for Milutin, please? Just a second. Može ovaj. The floor is yours.
Thank you. Thank you. Do you hear me, everyone? Yeah, perfect. Thank you for the introduction. I will be quick here, so I'm already introduced. I'm machine learning research engineer at SmartCat. We are a data and AI company, and we partnered with companies like Vantage Discovery to turn e-commerce platforms from simple e-commerce platforms with simpler search to something greater or more like personalized experience or personalized shopping. So why are we here? I'll be covering multiple topics, but the most important one is search engine inside e-commerce. That's the focus of this presentation. And we can start with problems that e-commerce platforms have. The most important one is lost customers, as you already know. Shopify did the analysis that I think more than 60% of customers that land on your e-commerce platforms go directly to query search or a query bar. And after that, 80% of them drop because they have frustrated experience or bad search results. So it's a really big problem, and we need to address it. And I will try to explain to you in simple terms how to fix those problems and integrate machine learning into your existing solution so you don't have these problems. So we will try to eliminate frustrated search, match products with customers, guide them to products, and make potentially personalized experience. And how will I do that? Well, with 3 magic ingredients. I separated this presentation into 3 parts, and they are query, retrieval, and ranking, or re-ranking, however you want to call it. So we will start first with retrieval, because I think it's the foundation of e-commerce platform and search engine in essence. And I will try to explain you what most of the companies that we work with do wrong and how to improve it. So almost every company that we have worked with do keyword search as a retrieval. And I want to explain to you why that's a problem and how to fix it with a simple example. So we want to buy this cute bunny that we have here. And product description may have been a pink stuffed rabbit toy for kids. Okay, so we want to type in a query, which will be pink stuffy rabbit. And if we do a keyword search, we will probably return this product because we have 2 exact keyword matches and 1 partially. So it's fine, okay. But what happens if our product description is just a tiny bit different? In the essence, it's the same. Rose bunny cuddly toy for kids, but the problem is that our keyword algorithm won't return this product, and it's a basic thing. And also it applies to queries. If I change my query to not have pink or a rabbit, it will be a failed search. Okay, and how to fix this problem is to introduce semantic. And we can see some of the good example of semantic here. So I don't want to tell you that remove completely keyword search from your existing pipeline. No, I want to tell you that you need to add semantic search into it. And what semantic does is takes synonyms like laptop and notebook computer and understands that those things are really similar and we should return possibly the same results. For some customers, they are also the same. And also, it understands context. So if I'm talking about apple, fruit, it understands that it is completely different from Apple company that you already know. And also, it can handle those emojis are not showing that good, okay? It can handle multiple languages. So we have shoes and zapatos on Spanish or cipele on Serbian. So it will handle multiple languages depending on the model that you are using. The models are also called embedding models on LinkedIn or social media, so probably you heard it about. And in summary, what's the most important thing is now you will have the semantic understanding. You will move from basic keyword matching, and also you will be able to return products even though the description of a product is not the exact match. Okay, so that's the first part. And also we can expand this. This is the first thing that we can do, but we can go even further by introducing LLMs. So bear with me. We call this stage LLM embellishment. If you're in an e-commerce or you work, you know that product descriptions are not that good. Potentially, if your customer is writing a product description, it will be really bad. Like on Amazon, you can see and try and you will see the description that some descriptions are really bad. And how to fix those is we can take an image of a product and some raw description text, create a prompt that will work for our domain, depending on what do you want to sell, and feed it to some kind of LLM. Here we have Cohere. No, here we have Claude, but it can be OpenAI, whatever you want. It doesn't matter. And you can have specific product description that's embellished. That's why we call it embellishing. And it can have title, description, technical specification, features, entities, ideal use cases. Those are better for discovery, and it will generate you better retrieval results immediately. We saw increase of around 30% for search when we introduced LLM embellishing for product description. And that entities will be quite important in the next part, so bear with me. Remind that we can get entities from LLM embellishment. So I think I will close the first part of retrieval with this, how to use machine learning or general models that are available to us to improve your search. Now, we will go to query understanding. And like on this meme, we have a lot of customers. I think that 90% or more people who do e-commerce treat every query the same. We get a query from a user and pass it to a retrieval pipeline, and that's it. We don't think about it. But I think that's really wrong, because there can be completely different queries, and they need the completely different pipelines in order to return the results. And I will show you some examples. Here, just a second, here we have basic query, which is Batman Lego sets, okay? And I would say that this user really knows what he or she is looking for, and I will classify it as a direct type of a query, and I will immediately pass it to a retrieval pipeline. I don't have to do anything. If my pipeline is working good, we will get these good results. Okay, this is a simple example. But what about this? Okay, it says 9-year-old superhero birthday party. I guarantee you that almost none of e-commerce platforms have these products. It doesn't exist. And I will classify this as an exploratory query where our customer doesn't know what he or she is looking for. They need help from us. And you cannot pass this query directly and expect to have good results. Okay. And I think in 90% of example, you will return bad products, not related to this. So how to fix this? You can create different pipeline for retrieval for these queries. If you classify the query as exploratory, you can first pass it to a small language model and ask it to generate different groups of items that are related to this query. Like here, it generated kids' costumes, potentially for a group of products, and birthday decoration. Okay, that's the first step. And in a second step, we ask it, or in the same way, at the same time, we ask it, generate us a query that will return products for this group. Okay, and possibly in this first group, it will generate superhero kids' costumes that we will use to search our pipeline and get the best data possible. And in the second, we can maybe have 9-year-old birthday decoration and get these results here. and immediately you have completely different shopping experience and completely different results. Okay. And also, as before for the previous ingredient, we can go even further and understand queries more. So sometimes for some e-commerce platforms, query is the single thing that they have from a user, nothing else. So you cannot treat them just passing into a retrieval pipeline. You can use it more. And we call this a query breakdown. Okay. What we want to do is first gather some entities that I was mentioning before. Like here we have material, style, product category, price range, usage, and etc. When we defined our entities, we can ask a NER or BERT model to detect the parts of the queries that match to our entities. So for example, leather can be detected as a material, crossbody as a style of a product, bag will be a product category, under $200 will be price range, usage is business casual. Okay, and what will we do? We can apply filters while searching. That will help us how? Well, we won't return rubber bags or some denim bags. We will only return leather bags, okay? Also, we won't return backpacks. No, we will return crossbody bags. And results will be in our price range that user detected, under $200. So this is a really cool thing. And from our experience, it's not that hard to train the model and get the good results. And I think that will be the end of the second part of this ingredient or the recipe for better product search. And the third and the last part will be re-ranking. So what's re-ranking? We get some results from our retrieval pipeline, and we want to rearrange them. So the first examples to be the most relevant, and the last examples to be the least relevant for the user query. Why? Well, just ask yourself, when was the last time you went on a second page of a Google search? So you want to have the perfect results right at the top, and that will maybe possibly trigger an impulsive buy. If a customer searches something, gets it immediately, and buys it immediately. Okay, starting as before, I hope this tent doesn't fall apart. We can use some basic approach. I don't know why some text and queries are moved, but okay, here it's stated winter running jacket. Okay, if I search maybe in your e-commerce platform, this is just an example. Before re-ranker, if I search this query, winter running jacket, I may have results at first place that are not that related to running. They are more fashionable and heavy. But after I pass it to a re-ranker, I can get results that are more related to breathable wear, lightweight, and possibly fit for running. And how? We call this a smart text matching, and it's quite cool because you can use a model only with text to get a re-ranker. Why is it? Okay. Why is this cool? Because all of you, if you use or have e-commerce platforms, have this information. You have a query. If you have a customer, you need to have a query. And you need to have products. So you have both things that you have to do a re-ranker. And you can just pick and place a re-ranker model in your pipeline and get immediately better results. Because from our experience, and you can read a lot of papers, every search will be improved even with the slightest re-ranker model that's really small. It will improve your search greatly. And this model for all of you engineers is called cross-encoder. So it takes a query and the product together, not separate, and can analyze the relationship between two texts and give you a score of how good this product is matched to this query. It's really cool, and you can use them out of the box, and they are open sourced mostly. Okay? And also we can go even further to improve our ranking, same as before, by making it personal. And how do we make it personal? Well, with engagement signals. Those are the data that customer is always leaving to you, to your e-commerce platforms, but it depends if you are saving a note in them. The most signals that we use are purchases, clicks, how much did the user spend on this item that he was looking or she was looking at it, and did it add it to a cart. These are really powerful signals that you can use later to retrain your re-ranking model and make every search to be a personalized. So if you track your customer and their history about purchases, you can create a model that will basically create for this user a personalized experience. And everybody wants a personalized experience at the end. And another animation, I hope it works. It works, thank you. If you haven't already figured it out, I really like Legos. So all of my examples are with Legos. So how does the search and re-ranking are combined and work together? First, if I want to search for 2x4 brick in a red color, I will eliminate all of the results that are not 2x4. That's basically a search and gather all the results. But they will not be reorganized as I wanted. Red one is in the middle. And then we do a re-ranking, possibly by color, and place my brick that I was looking for at the first place. And then you have the perfect results and no more frustrations, okay? And some key takeaways from this. So what you want to do if you have an e-commerce platform and you are thinking about adding machine learning to our platform to get better experience and more customer, first, take a look at your retrieval pipeline. This is a foundation. If you are not using semantic search, start immediately, gather results from keyword and from semantic together, and return those results. They will be better. Also, smart query understanding. Do not treat every query the same. So not all queries are the same, and you cannot pass them to a one single retrieval pipeline. That doesn't work. You will get the results, but they won't be perfect, okay? So possibly add query understanding to your pipeline. And the final thing is use re-ranking. In every search or whatever pipeline that returns results, when you add search, you will have better results, okay? So the quite important part in this equation will be ranking and possibly engagement data. If you have an e-commerce platform and you are not noting results from your customer, purchases, engagement, how much time did they spend, you won't be able to create a personalized experience probably. And if you are not thinking about adding re-ranker right now, I suggest you start noting this data immediately, but because in the future you can use them. Okay. And yeah, that's it. Short presentation about ML. Thank you. I like ML and e-commerce religiously, so I post a lot of things and data sets, open source, freely, and tips and tricks. So this is my LinkedIn, you can follow me. And if you are confused after this and you want to integrate ML, and you want to integrate ML into your existing pipeline, you can reach out to SmartCat, we can help you. So if you have any questions, I'm here, or if they are longer, we can talk about at our booth, at SmartCat booth. Thank you.
Questions?
We have another microphone. Okay, perfect.
Hi, thanks for the presentation. I have a question. Which attributes, for example, for a product, do you consider that are important in this semantic search? For example, maybe titles are mandatory, I guess, but for example, descriptions, maybe images also. So what do you think?
I will start with titles. That's the must in e-commerce, and a lot of open source data sets have titles. The next thing will be description. I think they are greatly explain the products, and working with text, in my opinion, is easier. And I will place images at the third place. They are more descriptive, have a lot of information, but it can be noisy depending on an image of a customer that gave you. And the last thing I will put like features or some technical details. maybe about the ingredients, something additional. That will be at the last
Like
place.
keys, for example.
Like?
Keys.
Yeah, yeah.
Okay. Thank you.
No problem.
Hi.
Hi.
Thanks, great talk. So I have a pretty specific use case
Okay.
where I have a bunch of products that are named pretty similarly. So
Okay.
semantic search doesn't get me really far.
Uh-huh.
The only difference is, let's say, the dimensions of those products. Like you can
Like
imagine.
IKEA, you have one table but in a different dimension, something like that?
No, I have let's say 20,000 different screws.
Oh, okay,
And
okay.
they are all screws, like wood screw, wood screw, wood screw, and then dimensions. So currently, I'm exploring some different ways to do this re-ranking part.
Okay.
And I'm implementing something really naive. I'm just taking all the numbers and comparing it to the query. But I was wondering if you had an opportunity to work with some data that has pretty similar product names, and
Okay.
then you need to...
I think cross-encoder is not for you because it's based on text. And LLMs if you think they do good with numbers, they do not. DeepMind had, I think, a paper where they showed that calculations and etc., stuff like that, they do not work with LLMs. So I would take the dimensions that you have, do some feature engineering, and create a small model that can possibly rearrange your results. You can maybe use a embedding model for a query because you will possibly have a text description. Query will be text, and use these numbers but numerically in the other tower. You can look it up. It's called two-tower model re-ranker. That will be a better approach for you. So maybe combining text from a query and dimensions of our object. I think that will be better.
Thanks.
No problem.
No more questions?
Okay.
Okay. Thank you very much, Milutin.
Thank
It was
you.
a great talk.
Thank you.
Thank you for your time.